Welcome to ClickMyProject.com. Now we are going to discuss about natural based prediction model of a bug reports based on ensemble machine learning model. Let's discuss about the abstract of this project. Bug report prediction is the task of automatically predicting the severity, priority, or other attributes of a bug report based on its textual content. This is a challenging task because bug reports are often written in a variety of styles and the information they contain can be incomplete or ambiguous. There are a number of different approaches to bug report prediction. One common approach is to use a machine learning model to learn from a dataset of historical bug reports. These models can be trained to predict a variety of different attributes such as the severity of the bug, the component of the software that is affected, or the effort required to fix the bug. Another approach to bug report prediction is to use a NLP technique to extract features from the text of the bug report. These features can then be used to train a machine learning model, or they can be used directly to make predictions. Now let's see the flow diagram of this project. Initially in the start page we are going to select a dataset. So we are going to select a dataset using a Kaggle, UCI, or a GitHub repositories. The dataset here we are using is a bug report dataset, and after selecting dataset we are going to pre-process the data. So pre-processing is nothing but removing null values or missing values. So here there may be some missing values, so we are going to replace those values with the 0. So after that tokenization is going to happen, because here some of the text values are here, so we are going to tokenize those data. So if there is a sentence, we are going to break that sentence into small portion. So this is called as a tokenization. After that the data splitting will be happen. So we are going to split the data set into train and test. In the train, most of the data will be in the train and the remaining will be in the test. It will be split in the ratio of 70:30 or 80:20 or 60:40. So after that we are going to do a vectorization. In this vectorization we are going to convert the tokens into vectors, and after that we are going to classify the splitter data. So using a random forest and decision tree algorithm, here a random forest gives some more accuracy than the decision tree. So we are going to further move on to the prediction using a random forest algorithm. So in this data set it contains a multi-class such as blocker, critical, major, minor, normal, trivial. So we are going to predict these label values using the test data. Performance matrix here is referred as the accuracy. So accuracy will be calculated using the model, how accurately it is predicting. So remaining will be considered as error rate. So here we are going to compare both the random forest and the decision tree algorithm using a graphs, and shows the result as how the accuracy is differ from both the algorithms. Now let's see how to run this project. Initially we are going to load the dataset. That dataset consists of severity code, bug ID, creation data, severity category, and etc. So it contains 19 columns and 700 rows. So after that we are going to do a EDA for a label values. So this is the EDA of the dataset, which means a normal label contains the most of the values, and some of the values is a trivial, minor, major category, and critical, blocker, and so on. So here we are checking for the missing values. So there are 9 missing values in the column called the long description. So we are going to replace these missing values with a 0. So after pre-processing the data, it was replaced with a 0. So after that label encoding is going to happen. Label encoding, why we are doing is we just replace the string values with the numeric values so that the machine can understand easily. So after that the tokenization was done. So these are one of the rows which is tokenized. So in the data splitting extrain, so we are just splitting the short description in the extrain and the label values in the white, and in the extras the remaining values will be setted. So after that vectorization is happening, so we converts the tokens to vectors here. After that we are doing a classification here. Random forest algorithm gives 82.14 something accuracy. In the decision tree algorithm it gives just a 75, so we are going to predict using a random forest algorithm. So here random forest algorithm is efficient, it is compared with the decision tree algorithm. So after that the comparison between the random forest and the decision tree is shown here. So in the prediction it is predicted as a minor.